Here we go. All right, so what's that first thing asked? It says, determine if it's true or false. Shoot, I wish I would have numbered those things. I'm gonna go ahead and number them. So 1, 2. Okay, here we go. All right, so consider this polynomial. Is number 1 true or false?
False.
False what?
Degree of 6.
Degree of 6, isn't it? In the degree 6? Okay. F has only real zeros. What are the zeros of F? A, B, and C, which are real numbers. So I think that one's true. Yesterday, I can't remember where, but yesterday we ran into a problem where a couple of the roots came out of this. So we said we had plus or minus 4i. Remember that problem from yesterday? And that one would have imaginary roots, but this one is completely factored, all real numbers. The graph of f passes through the x-axis at x equals c, but bounces off the x-axis at x equals b and x equals a. What's false about that?
It's not going to bounce. A also bounces.
At x equals a, we squiggle, don't we? That's not a very good math word, but you know what I mean, right? We squiggle through at x equals a. We definitely bounce at b, and we pass through at c. The graph of f has 5 turning points. All right, so I want you to think about that for a second. Can you visualize what this thing looks like? What degree did you say it had? 6? And I don't see a negative out in front of it there, so it's going to start up here, right? And I have no idea what A, B, and C are, so I'm just making up 3 points here. A, B, and C, there they are. And I know the graph does what at A? Squiggles. So I squiggled at A. And what does it do at B? Bounces. And what does it do at C?
Passes through.
Passes through. So that's what it looks like. How many turning points does it have? It has a turning point here. It has a turning point here. And it has a turning point here. So that one has 3 turning points. So that's a false. It has 3. The limit as x approaches infinity is infinity.
True.
Is that true? Yep, that's its end behavior, right? Up. That's it true. The limit as x approaches negative infinity is negative infinity.
False.
False. The limit as x approaches negative infinity is still infinity, isn't it? Up. The graph of f has a y-intercept at negative a times b times c. You think that's true? Let's make up a problem real quick here and see. Let's say x plus 2, x minus 3 squared, and x minus 5. Remember, a, b, and c are real numbers. Can they be negative numbers? Yeah. So I got a -1 in there. All right, so where would the y-intercept of that be? I'm going to take 2. Remember, c is -2. I'm going to take 2 times 3, because C, that's A, I'll call that A. B is 3, and C is 5. So what would my y-intercept be? 2 times 3 squared, oh wait, is that cubed? So 2 cubed times 3 squared times negative 5.
Why does negative 5 have to be negative and the 3 doesn't have to?
Because we're squaring, oh yeah, that doesn't have to be negative. Oh wait, no, we're squaring that one. So if you put a 0 in here, that would be negative 5. If you put a 0 in here,
It's
that
just
would
always
be
gonna be
positive 3 squared. Yeah, that term is always gonna be positive. This one, if it had a negative and it was cubed, it would stay negative. I'm trying to figure out what's going on here. So, my values are negative 2, 3, and 5. Those are my C values. This one is squared and this one is cubed. So that would end up being a negative answer, right? That isn't right, is it? I think this is false. Because if that's A and B and C, did I do my math right? That would, my y-intercept would be 2 cubed, 3 squared, and negative 5. So that's going to be a negative answer. But if I do what they say and take A times B times C and make it negative, it's actually going to turn out to be a positive answer. Then that's false. X minus A divides in evenly, true or false? True, because X minus A is a factor. F has only positive zeros. No, because when we say X minus A, does that mean A has to be positive? No, it could be X minus negative 2. Right? So that's a false. That's a false also. All right, anybody have any questions about those? This one was the only, I couldn't figure that out. I had to do an example to figure that out. Okay? All right, what about number 2? Use the graph to answer questions A and B. On which of the following intervals, review question, is the rate of change positive and decreasing? So rate of change positive means what? Going up. Rate of change decreasing means concave down. So where are we going up and concave down? From negative 1 to 2. No. How about 3 to 4? Nope. How about 4? Oh, how about, oh no, 4 to 5. I need to be concave down, right? So 4 to 5 won't work. I hope it's 5 to 8. 5 to 8. Are we decreasing and concave down? Yeah. Where is the function decreasing and the graph concave up? Now, if the function is decreasing, that means it's going down. So where are we down in concave up? Negative 2 to 1. No. Negative 1 to 1. I think negative 1 to 1 looks good. What do you think? Are we going up and we're concave up? Oh no, we gotta go down, don't we? I'm sorry, no, that won't work. Gotta be going down. 3 to 4. 3 to 4. Is that a winner? Going down and concave up? 3 to 4. More true and false. Here we go. Number 3. Okay. G has a negative instantaneous rate of change at x equals 3. Now, rate of change is slope. If you drew a line tangent to the curve at x equals 3, would the slope of that line be negative? Yes. The answer is yes. Instantaneous rate of change is the slope of the line tangent. So you just draw a line tangent, it's negative. That's true. How about the second one? Plus 4, plus 1, minus 3. Would you say those are all factors? Yep. G is an odd function. Okay, how do we tell? What does odd mean? Take a point on the graph. Let's take, how about, are there any good points? No, they're all awful. All right, how about, are there any good ones I can pick? All right, I'll just use negative 2.694, negative 3.149. That point is on the graph, right? If the function is odd, what point would have to be on the graph? 2.694 and 3.149? Because if you change the sign on the input, you also change the sign on the output. So, I know they didn't plot that for me, but is that point on the graph? 2.694, 3.149. Oh, I don't think so. It's close maybe, but
This is 4.
yeah,
You could just use the zeros, right? Like,
the zeros.
like if you said like if it's going through negative 4, then it'd have to be going through positive 4 on the other side.
Okay, because you gotta change the zero to just stay 0, it
Yeah.
wouldn't change. Yeah, okay, and that doesn't work either, so I think this is a no, it's not odd. Also, what symmetry does odd have? Origin? Does quadrant 1 look exactly like quadrant 3 to you? No. So it doesn't have symmetry about the origin. So that's another way that you can tell. It is not an odd function. On the part that's drawn, we have a relative and absolute minimum at x equals negative 2.694. Is that true? Nope. It's a relative minimum, but why isn't it an absolute? Because at 3.5, you are lower. So it's a relative minimum, but not an absolute minimum. The leading coefficient is negative. We don't have the equation, but can we tell the leading coefficient's negative? Yep, because the end behavior is backwards. G is increasing from negative 3 to what? Is it increasing on that whole interval? No. Does it appear to have a point of inflection between negative 1 and 0? Yeah, concavity's changing in there somewhere. Absolute maximum at 5.186. Think that's true? Yeah? And the average rate of change on equal length subintervals is decreasing. So from 0 to 3.5 on equal length subintervals. So you could pick 0.5. So the average rate of change from 0 to 0.5, is that decreasing? From 0 to 0.5, would my rate of change be decreasing? Okay, what's rate of change? Slope? So look where x is 0, and look where x is 0.5. Is that curve going up or down from 0 to 0.5? Up. Its slope is positive. Its rate of change is positive. How about from 0.5 to 1? What's happening 0.5 to 1? Positive. Now, after that, it starts decreasing. But this says on equal length subintervals. So no. Part of them are increasing, part of them are decreasing. Alright. You understand that? It doesn't say the average rate of change from 0 to 3.5. That you could calculate. And that might be negative. It says on all subintervals in there. And some of those subintervals would be positive. All right, number 4 is, I guess it's solved, there's no directions, but we're solving number 4. So what are you gonna do? What's gonna be your strategy to solve this? I'm gonna draw my handy dandy number line and put some zeros on there. So I'm gonna have 1 at -9. I'm gonna have 1 at 0, and 1 at 3 and 1 at 4. Did I get them all on there?
Aren't they closed now?
They're going to be closed, yes indeed. Do I have all my points though? Yeah. And they're closed because of the or equal to part, right? That okay? All right, so now I'm gonna put in and because I've got squareds in there, I'm just gonna have to try every single section. So I'm gonna put in my -10. -10 would be positive, 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 negative. Does that work? Remember, this is what I want. Does that work? Putting in -10. No. How about -1? Does -1 work? That would be positive, 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 negative again. That doesn't work either. How about +1? +1 would be negative, positive, positive, negative. Hey, I think that works. Do you think so? Did I do my math right? If I put in 1, and then I'll put in 3.5, and that'll be negative, positive, positive, and then 3.5. I think that works too. And then 5. 5 would be negative, positive, positive, positive. That doesn't work. So this got some of you on our last quiz. Be careful. Clearly, part of the answer is 0 to 4. Would you agree with that? But what else? -9. Yep, we got -9 over here. If those had been open dots, then we wouldn't have that. We wouldn't have to worry about it. If they'd been open dots, though, let's talk about that for a second. That would really change the way I wrote my answer, because I wouldn't be worried about him, but I couldn't do this. I would have to do 0 to 3 and 3 to 4. Would you agree with that? If they'd been open dots. Alright, so determine if this guy is even, odd, or neither. How do we decide if something is even, odd, or neither? Plug in negative x. What would negative x be? 2 times negative x cubed minus 3 times negative x plus 9? Negative 2x cubed plus 3x plus 9? If it's even, then this has to match the original. It doesn't. So I'm not even. Would you agree with that? What has to happen if it's odd? I have to get the exact opposite, which would be that. So guess what? Neither. Yep, we're neither. Find the average rate of change from -2 to 1. So your setup, from -2 to 1, you'll have f of 1 minus f of -2 over 1 minus -2. So this is going to be my setup for my average rate of change. All right, let's look. What is f of 1? -1, very good. What is f of -2? 3, perfect. So my average rate of change is -4/3. Now, did everybody get that? Everybody understand where these numbers came from? Solid dots. The function values are the solid dots. Alright, 3 minus 2x to the 5th. 1, 5, 10, 10, 5, 1. I remember that from just a minute ago. We had it up here. Plus, I've done a lot of these. You know how to build the triangle, right? So you could get the 5th row. I got a 3 and a -2x. Somebody was complaining last period about having to write all this down. Kids, it beats the alternative. Yucky, yucky. Multiplying that would be a lot of writing. Okay, so 5, 4, 3. Now, I kind of just did that automatically. Does anybody have a question about that? Did I do something too fast? Are you okay with putting on your exponents?
It just counts down to the biggest
Counts down, other direction counts up. Or down from each, Okay, here we go. Anything to the 0 is 1, so I don't really need to write those two down. So what have I got for the first term? Feel free to use your calculator. I think it's 243. I think the next one is -810x, but I'm doing that, I don't know, I think that's right. Let's see, might be time for a calculator here, is that? I don't know, let me double check. Is that right? Okay. Now,
Maybe a section of these on the quiz where we can use our calculator.
but yeah. But I just did that without a calculator,
Yeah, just for
and I'm 65.
big numbers.
The age thing, Mrs. Ford, the respectfully, the age thing doesn't work for knowledge because you gain more knowledge as you get older.
Yeah, but you forget everything when you get older.
True.
Yeah. No, it doesn't right. Transpose 720. Is that right? 8 times 9, yeah. Check that one for me, is that right?
Yeah.
And the next one, that's gonna be plus 240. Check that one also, 16 times 3 times 5. And then negative 3, 2x to the 5th. Did it say expand? Oh no, oh crap, it said find the third term. Oh, shooty cutie. This is the third term, right? So I didn't really need to go through and do all of that other stuff. Good practice, but I only needed the third term.
But wouldn't it be negative 720x to the third, because you put it in standard form, that'd be the third term?
That is a great question. I don't know. So I'd have to accept both. Because if you turn, what you're saying is if you turn this binomial around, then you're going to get these things in the opposite order, and so the third term then would be that guy? It's a great question. I don't know. If you brought that up, if that was a test question and you brought that up, I'd give you credit.
For either.
But I give these people credit too. All right, use limits to describe the end behavior of this. So the limit as x approaches infinity, and the limit as x approaches negative infinity. This is an easy question because look at your polynomial. It has a negative coefficient and an odd degree. So what does that look like? Where does it start and end?
Starts.
Like this? So as x approaches positive infinity, this guy's going to negative infinity, would you agree? And then negative infinity is going to positive infinity. List all of the vertical asymptotes and holes. Okay, so what do we notice? We notice we can do more canceling, right? So we can get rid of that. We can get rid of that. So are we left with x minus 1 over x minus 4, x plus 3? Anything that's left in the denominator is going to be a vertical asymptote. So you have vertical asymptotes at 4 and negative 3. Anything that canceled and will allow you to plug that number back in. So for example, I canceled out a 1, and I can plug 1 in here, right? That's gonna be a hole. Now, I also canceled out a 4, but I can't put 4 into my problem, so that is not a hole. That's a vertical asymptote. This is a hole because I can plug 1 back in and I get 0. So the hole is at 1, 0. If something is going to be a hole, you must be able to get a y coordinate. Are we good with that right there, guys? Are we good with that?
So why is there not a hole at 4,
Because I can't plug 4 into my problem.
Because you can 0.
If it's gonna be a hole, it has to be an ordered pair. I can't get it. proportional inequality. So we're gonna go back to our number line. And we're gonna have dots at -2, -1, 1, and 3. Are we good with that? Are we okay with that? If with the location of the dots,
It's x squared minus 1. But it's not like all the parentheses outside.
Super confused.
what now?
X
X squared minus 1
Yeah, it's not like,
is the difference of squares,
oh, okay.
right?
I got it.
These are different, these aren't the same, 'cause that's +1, x minus 1. Okay, are my holes in the right, or yeah, my dots are in the right spot. Now, this is the one we have to be careful of. The symbol is nor equal to, but we're not gonna color everything in. We're only gonna color in the dots that come from the numerator. Because you can have zeros in the numerator, but you can't in the denominator. So are we good with that distinction? Okay, now we'll do what we do, so we'll try -3, that'll be negative, positive, negative, negative. Does that work? I'm trying to get a positive, so that doesn't work. How about -1.5? Positive, positive, negative, negative. That'll work. Don't let me make a mistake. How about 0? Positive, 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 negative. Nope. How about 2? Positive, 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 positive. That'll work. And 4. Positive, 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 positive. Okay. How does my shading look? So I cancel -2 to -1, and I have to distinguish here the brackets and parentheses, and then 1 to infinity. We're rolling through this. Okay, now we got the monster. Okay, what are we gonna do first here? We're gonna factor the whole shebang. Right? No, when we get this problem done, I'll shut up, I promise, but we gotta get this done. All right, so here we go. How does that top factor? What in the world am I going to do with that? I hope you're all grouping.
Yeah.
So x squared, x minus 6, minus 4, x minus 6. So that'll be x squared minus 4, x minus 6. So on top, I haven't done the bottom yet, on top, x plus 2, x minus 2, x minus 6. What do you think about that in any order? Good? Now, what about the bottom? Now let's take out the 2,
X plus 3, X plus 2.
and that's gonna be x plus 3, x plus 2. Very good, very, very, very good. So, I know this, I can cancel. So I have x minus 2, x minus 6, over 2, x plus 3. Is that all right? So let's start graphing. We've got it factored. Now we gotta start putting stuff in. So what do you wanna put in? What do you know? We're gonna have a hole, and the hole is going to be where x is -2. So I'm gonna plug it in. So -2 minus 2, that'll be a -4. And that'll be -8. And that'll be 1. So did you get, oh Lord, did you get 16? So -2, 16. All right, what else can I put in my picture? Zeros are gonna be at 2 and 6. So x equals 2, 3, 4, 5, x equals 6. Good, got that, perfect. All right, what else can I put in there? A vertical asymptote at x equals -3. Perfect.
Yeah, where is there this one?
There's going to be a slant asymptote because either look at the original or look at this. The power on top is 1 bigger than the power on the bottom. Right? So to find the slant asymptote, I need to divide x squared minus 8x plus 12 by 2x plus 6. Would you agree with that? That's the division I need to do. Now I'm going to do it synthetically. Avery, was your hand up?
Yeah, I know, like, I understand how you got the x squared minus x, 8x plus 12, but could you go back to the original, like, if you really
You
wanted to?
absolutely could go back to the original. Now, if you go back to the original, then you're going to have to do long division.
Yeah.
But yes, you can always go back to the original. I'm doing this division here. That's got to be a 1, so I'm going to divide all these by 2. So I'm actually going to be dividing 1/2 x squared minus 4x plus 6 divided by x plus 3. That's the division. If I do it synthetically, that's the division I have to do. So I'm just going to do it over here. So -3, and then 1/2, -4, and 6. So -3/2 or -1.5. I can do that, that's okay, because that's gonna give me -5.5. And I don't need anything else, because I could figure out what this is, but that's just gonna be the remainder and it doesn't matter. So y equals 1/2 x minus 5.5 or 11/2. So this thing has a y-intercept. I'm going to try to keep some semblance of scale here. Down here at -5.5, and a slope of 1/2. So up 1 over 2. So it's going to look something like that. My wacky y scale is messing up things. I'm gonna plot a couple more points. Not use slope, I'm gonna plot a couple of points. So there's -5.5. All right, if I put in 1, no, I'm gonna put in 6. If I put in 6, I actually get a -0.5. Oh, that looks terrible. But that's my slant asymptote. All right. Do I have a y-intercept? Let's put a y-intercept in there. What's my y-intercept? What do we get if we put in 0? 2? So my y-intercept's right here. pole, a y-intercept, and 2 zeros on this side of my picture. I'm thinking that it looks like that. What do you think? I know this asymptote is terribly wonky, but based on the information that I had, does that make sense to you? That's all I have though. I still need to graph the left side. Remember, the asymptote's like having a pair of scissors. You got a right piece and you got a left piece. What's the left piece going to look like? I don't have anything over there.
It's gonna be like.
Yeah, exactly. That's the point. You don't have anything over here, so it's gotta be down here. Because if it were up there, it would be crossing some axis, and it can't. So it looks just like that. Yes, you will have to graph something like that on your quiz. So, we have another review day. So that could be something, if you have a question about that, that could be something that we can do. So your job for Friday is to go back through what we've done, notes, homework, whatever, and figure out what we need to talk about on Friday. So you can use this review packet. I actually numbered the pages this time so it'll be easier to locate. But go through these and see what we need to practice. You can spend some time with the Big Ten, that sheet I handed out. That is videoed and will be posted. So if you want to do that on your own, that would be fine.